Hi again! Let's pick up where we left off. We've got all the code needed to train our first algorithm with TensorFlow 2, so it is time to run it. Sadly, the result is a bit underwhelming. We get nothing more than an output signifying that the model has been trained and stored in an object with no information about the training. The reason is that we set verbose to 0, which stands for silent, or no output about the training is displayed. So, therefore, if we set verbose to 1, we should get a progress bar. Let's try this out. Unfortunately, for the current version on TensorFlow and its integration with Windows and Jupyter, we get the whole output in text form. However, it's not such a big deal, as we can still clearly see all the information needed. For those of you coding in other environments, this may be a more pleasant experience, like this one for instance. Because of this lousy output, the cleanest form of information about the training can be found when verbose is set to 2. This indicates we will get 1 line per epoch, which will allow us to follow the development of the loss function over the training. The first piece is a timer, tracking the time it took in seconds to complete each epoch. For all epochs in this simple example, it took 0 seconds per epoch. The second output available on each line is the current value of the loss function. As we scroll down through the epochs, we confirm that the loss is in fact decreasing. So, our algorithm has worked as intended. Alright, as we discussed already, we generated the function 2 times x minus 3 times z plus 5 plus noise in order to be able to assess how our model did. You should be aware that in a real-life situation, you'd never know the exact relationship, so it wouldn't be possible to confirm how well your model has fared. Anyway, if we check the weights and biases, they should be 2, minus 3, and 5. There is a convenient built-in method called getWeights that could be applied to each layer for this purpose. Therefore, we write model.layers square bracket 0 getWeights. Model is the model that we created. Next, we must specify the layer we are interested in. In that case, the only layer, so that at position 0. Finally, we have to apply the method getWeights. The output is a tensor with 2 arrays, one for the weights and one for the biases. In this case, bias. As anticipated, the weights are approximately 2 and minus 3, while the bias, 5. This is precisely the information which confirms that our algorithm has indeed learned the underlying relationship. Great! What if we wanted to predict values using our model? To predict values with our model, we use the method predictOnBatch. The batch here is the data that we provided with. So, let's write model predictOnBatch and feed it with the training inputs. The result comprises an array with the corresponding outputs for each of the inputs. In fact, these are the values that are compared to the targets to evaluate the loss function. To be precise, these are the outputs based on the trained model, or in our case, the outputs after 100 epochs of training. Since the outputs are compared to the targets at each epoch, it may be interesting to compare them manually. To achieve that, we can display the training targets and round all values to 1 digit after the dot, so they are easily readable. What we see is that the outputs and the targets are very close to each other, but not exactly the same. Alright, finally, we can use the same technique as in our previous minimal example. We can plot the outputs against the targets. Since we expect them to be very close to each other, the line should be as close to 45 degrees as possible. And that's precisely what we get. So, we have successfully built our first machine learning algorithm with TensorFlow 2. We can't call that deep learning yet, but we got somewhat acquainted with the package. In the next lecture, we'll explore how to get it even closer to our NumPy model. Thanks for watching.